continuing with the June 2017 exam for geometry, what we have is, I'm going to graph these. I'll pause it and graph these, but let's talk first about how are we going to prove that PQRS is a rhombus. There's several ways we could do this. Properties that we can prove on a graph, remember, okay? Those are that are easy. We can't prove a lot about angles, but we can prove some things about diagonals. We can prove something about sides. I would go for the four sides congruent. So to do that, we're going to calculate the distance of every side. Okay, that's probably going to be the quickest way to prove it's a rhombus. There are options with diagonals. Okay, we could show perpendicular and bisect each other. That's going to get us enough for a rhombus as well. So that would be perpendicular bisect each other. That would be two midpoints for bisect each other, two slopes for perpendicular. If we do the four sides congruent, we're going to look at four distances. And I think I'm going to go for that, depending on what it looks like. Prove that it's not a square. Once we have a rhombus, probably the easiest way is to show adjacent sides not perpendicular. And that's going to be easy with slopes. You know, if the slopes are not negative reciprocals, then it's going to be not a square. All right, so I'm going to pause it, graph it, and then see which method is probably going to be the best for this proof. So back. Now, after taking a look at the diagram, I'm going to go with the four sides congruent. The reason I was hoping maybe diagonals, if the diagonals happen to be, you know, say a vertical and horizontal lines, that would make it really easy to use for diagonals perpendicular and bisect each other, but that didn't happen. So I figure, well, we might as well go with four congruent sides. So what I'm doing right now is calculating. I'm going to calculate the length of each side quick. So we're just going to go and kind of complete these right triangles. All right, I'm going to assume that's 7 and 1, probably 5 and 5. Just count them, 7 and 1. All right. So what's going to happen is I'm going to show the length of every side. Now, by doing this, you're kind of communicating to the person grading what you're doing. That helps a lot. You know, that helps your score. So that if something were to go wrong, they're more apt to give you some partial credit. Okay, so let's check out PQ first. It would be 5 squared plus 5 squared equals, we'll just call it D for distance. That's going to be 50. So just some quick mechanics here. And PQ is the square root of 50. Just leave it like that. Because if the other ones end up being the square root of 50, then you don't really have to worry about that as much. You don't have to know that it's 7.1 or something like that. Okay, I'm going to pause it. I'm going to go get the other distances so you don't have to go through that tedious step there. Okay, back again now. I performed all the tedious mechanics, the work that has to be shown. Now, I know my students in the past have asked me, well, why do we have to do all 4 of them if, you know, we did 2 of them? You know, I just don't want to take the risk. Okay, it's something that should be there. If you choose to do it your own way, then we also choose to potentially lose some credit, you know, depending on who scores your test. I wouldn't take off as long as you explained yourself, but I can't score your test. So just to be safe, do all 4 of them. It's going to cost you an extra 30 seconds. Okay? Now, here's the key to this. There's all of your evidence, is what we like to call this. Okay? Your calculations are your evidence. Now, I'm going to use this evidence, summarize what it tells us to complete the first part of this problem. Okay? So what I'm going to now state is that PQ is congruent to QR, and that's congruent to RS, and that's congruent to SP, because they have key is lengths that are equal. Now, please avoid this pitfall of some students. Don't say because they are equal. Be specific. Communicate properly because they have lengths that are equal, right? Because we calculate slopes, we calculate all sorts of different things. Just again, make sure that you're clear and you're communicating well. That's what we're looking for in geometry. Okay. Now, PQRS is a rhombus because it has 4 congruent sides. Now, we haven't quite finished what we're out to do. Okay, we did get a rhombus. Now we need evidence that it's not a square. Okay, so here goes. I need more calculations. I'm going to calculate the slopes of 2 sides. Okay, now if you look, I'm going to pick PQ and QR. Now, it's 5 over 5 for PQ. Rises, the change in y is 5, the change in x is 5. Okay, now, QR, this is a little more tricky. It's a slope of, you got to be careful here, -7 over 1. The change in y is 7, the change in x is 1, and what we're doing is we're heading down as we move left to right. Okay, so now we can summarize what this tells us. So PQR, sorry, let's make this statement. Let's do this first. PQ is not perpendicular to QR because their slopes are not negative reciprocals. Please don't say opposite reciprocals. It is negative reciprocals that we use. Okay? Now, this makes angle Q is not a right angle because its sides are not perpendicular. So PQRS is not a square because it does not have 4 right angles. $36. Okay, so let's say this is where Freda is standing. Okay, let's say that angle of elevation, let's say Freda is looking at the plane over here. We're assuming line of sight should be straight across, you know, at her level. So right parallel to the ground. Okay. Now, angle of elevation would mean now the line of sight, she's elevated her line of sight from 0 degrees to an elevation of 15 degrees. And then here she spots this plane, called P for plane. Let's see. The altitude that this plane is maintaining is 6250 feet. Okay. 1 minute later, the airplane is at an angle of elevation. All right. So let's assume for a minute, okay, that the plane maintained height. Okay. And let's assume it did not pass over her head. It just got closer to her. Okay. So what we have is we've created basically two triangles. The one where the plane is closer and the one where the plane is further, but the heights are the same. Okay, so let's consider that. So Freda, the plane. And we'll call it C for closer plane. All right, the plane moved closer. Okay, so they're still at, what was the 6250 feet. Both of them. There's the height. This angle of elevation is 15 degrees. This angle of the elevation is 52 degrees. Right? Yeah. So what we're going to do is, and that is if it didn't pass over her head. I'm assuming if it passed over her head and went the other, she's looking the other way, they would have said that. So let's assume that it didn't pass over her head. Let's call this, okay, let's just call this X, and this is going to be Y, and then we're going to subtract them. So what it looks like to me is we're going to use a double trig problem. So we're going to use trig twice. We call it a double trig problem. And what we're going to do is, these are both legs, opposite and adjacent. The hypotenuse is not going to be involved, but I'll just label it. Here's the 52, that's opposite, that's adjacent, and again, hypotenuse. Now, if we wrote down our trig functions, or acronym for our trig functions, I should say, sine, opposite over hypotenuse, that's out because the hypotenuse is not involved. Cosine, adjacent over hypotenuse, same thing. This one's tangent, opposite over adjacent. So tangent's going to define the ratio of the sides, opposite to adjacent. All right, let's solve for x first, which is the larger one. So tangent of this 15-degree angle. Tangent will tell us what do we expect the ratio of the sides, opposite to adjacent, to be for a 15-degree angle. Okay, so let me go get that. So now this is just the mechanics I use. Tangent of 15, I convert that to a decimal, 0.2679 to 1. That's the ratio of the sides we can expect opposite to adjacent. Now opposite is 6250 in our problem. X is what we're looking for, which is going to be adjacent. Okay, again, it's all just mechanics, and I know everybody does this differently. Multiply those, it's still 6250. Okay, divide by 0.2679. And some differences in rounding might take us to slightly different numbers. So if you get a slightly different number than me, I wouldn't worry too much about it. When you're using your Inspire, it'll store old answers, and then you won't have rounding problems. All right, so that is how far it is, the plane is away on the x-axis, okay, the horizontal distance. So this right here, to start with. And that's in feet, I believe. Yes. Okay, so now we'll solve the other one. Okay, so that, sorry that they're crossed, but that one's there. So now I go tangent of 52 degrees. Again, it's going to be opposite over adjacent. I'm just going to run basically the same mechanics. Tangent of 52, I get 1.2799 to 1. And that is 6250 over y. Cross multiply. Divide. And I get approximately 4883. Okay. So now what I do is the change, or the, the distance traveled in the minute is, and then we're just going to subtract these. And this is where I might have had a little bit of rounding error, because I'm using my phone instead of the Inspire. Right there, I got 18,442.88, and this is feet. So this is how many feet the plane traveled in 1 minute. Seems like a lot, but when we convert it, you'll see that it is actually a relatively slow plane. So what I did was I took the feet first. I've got two conversions to make. I've got to change it to miles first, because my goal is miles per hour. Now you can, I believe this is going to be on the reference sheet. 5,280 feet is equal to 1 mile. Cross multiply. Now the reason I do it with proportions is this is just something that I teach in this course. If I was teaching science, I'd probably use dimensional analysis. But we use a lot of proportions in this course. So it kind of fits. It makes some sense here. So not learn anything different. About 3.492 and some change. Again, that might be slightly different. I have some rounding errors based on what I used for a tool. I already used X in the problem. I shouldn't use that. Should call it something else. We'll call it Z. Okay, so this is how many miles per minute, right, because it was in 1 minute. Now I want to convert that to miles per hour. So there's 1 hour is 60 minutes. You can set up a proportion again or just multiply by 60. So 60 times 3.492. As long as the teacher sees you multiply by 60, now they're going to give it to you. Now, again, I get 209.57 something. There could be some differences here, so I'm going to round that based on this number to 210 miles per hour. All right, was there any more to the problem? Speed of the plane, nearest mile per hour. Okay, that's it for this exam. Good luck.